Not a problem. But yeah, once you get to this page, just sign in with your NetID and password. This is hooked to our Active Directory system. So once you do that and hit authenticate, it's going to come to kind of a pre-auth splash page saying pending access. Once you get there, shoot me a message, and if we're not already talking, and I'll go ahead and make sure that you're approved as a active user on there.
Cool. Okay.
So yeah, kind of what I was going to focus on, and we can absolutely change gears and focus on any other specifics that you want. But kind of what I was gonna look at is how you can then take, this UI, obviously having the functionality of adding files and pictures and being able to do web search and all that is great. But how do you then kind of power up these LLMs to start working functionally for you instead of just being kind of a cool toy? And so there's a couple of ways to do that. And so I was going to show you through this Open Web UI portal a little bit more of kind of the fine-tuning knowledge base articles and uploading data to those, and then what you could do to kind of fine-tune your agents, but then also look at this other service called N8N and show you this is quite a bit more comprehensive in terms of what it can do. I think we kind of jumped into this a little bit, but as you can see, you can get very sprawled out in all of the different tasks and tools and processes that you want to build. So I was kind of going to go over that. Is that kind of on par with expectations, or did anybody else want to look at something different?
Sounds good to me.
Perfect. Okay, and I know Nate had sent over some data to kind of play around with and looking at. Once we get into the N8N piece, excuse me, we'll kind of pop into that use case if that's okay, and just ask some questions. So I think there's very much a possibility to just kind of one shot hit that, but it might be something that we want to kind of split up over multiple steps of the process. But yeah, we'll get to that in a bit. So looking here at the workspace and kind of the knowledge base, I guess to step back and just briefly explain my thought process on agent versus LLM model. What do I think is kind of that delineation point or demarcation point? And that's going to have specific organizational or institutional knowledge as well as functionality. So some of the POCs here, like UAM agent, obviously has the UAM markdown files, has the sitemap, so we can link those up. But I don't know if I would really call it an agent. It's just a LLM that has access to some of that information. Now, if we then created a RAG database and went through that whole kind of scraping methodology of going out to just the UAM URLs in the sitemap, and just to show you what that looks like. So virtually every site has one of these, and if they don't, they have a robots.txt or a LLM's text.txt. And ultimately, this is just a list of all of the URLs and some metadata around the changes and publications of those pages. So you can very quickly go through, load these into a crawling utility, and just start pulling down all of the page HTML. Then what you want to do is, vectorize that, take the body out, but also use the metadata to kind of contextualize and enrich that chunk, if you will, and give that back to the LLM in some meaningful form. That gives you immediate access to all the URLs. It gives them kind of a running list of updates to make sure that they have, all of the modifications captured in any given time. And it's just a much more, elegant and effective way, in my opinion, of running it. And that would be more of what I would consider an agent. However, it's all about what we have access to and what we can use. So taking that, for example, getting into the edit screen, base model, again, just GPT-5 chat. I didn't really get too creative with the tags or descriptions or anything. System prompt came from, again, the system prompt generator. Gave it, how to use the UAM URLs, how to line those up with the different sections, the policy sections, and then how to kind of format the hyperlink to those sections. And then going into the collection here, let's jump into that. This has those three parts. It has the overall policy sections. It has the URLs for those sections, and then it has the actual UAM, which I converted from PDF to Markdown for ingestion purposes, but same data, same information. It just didn't have any of the actual page URLs. So letting the LLM do the heavy lifting on comparing those lists and saying, okay, well, I've got section 1501. Let me go into the policy section or the sitemap and match up the URL to that. So those are the three pieces of data that I give it. And then again, going basic instructions. We really could tailor these a lot more and get much more specific. I haven't really had the time to sit down and hit each one more than just a proof of concept. So you can see it has some specific U1R information. Again, back to the files it has, but then it also gives some response information. So if you want to use that, we could say, what policies do we have? And actually, go ahead and add a model to compare it, what the baseline model would do without that data. Around travel. So as you can see, right off the bat, it says, hey, we don't have access to your specific information. But then over here on the left, on the POC agent, it absolutely does call out specific sections, gives a hyperlink. Fingers crossed in a live demo that this works. Hey, look at that. So it brings us right to the policy page. Again, because it's taking those three lists and comparing and formulating a URL hyperlink that goes over the top of the policy number, there's a lot of moving pieces that could go wrong there. And I've absolutely experienced many times where those links are not correct. See, perfect example. It would jump to this one and just not know how to format that URL. So there's very much some fine tuning, but again, that kind of goes back to the data ingestion. If we were crawling those sites and ingesting it into the vector database as HTML with all of the metadata, it would be a lot cleaner, in my opinion. But that's something to work on. So really, if you want to go further in this UI, you can go into custom prompts. Where it says discover a prompt. Excuse me. Sorry about that. This actually takes you to a public page where if you join the community, which I have not, you can go in and look at all sorts of custom prompts and different options. There's, I would be very weary of just loading up other people's code, but in terms of prompts and in some of the basic tools, you can kind of read through that syntax and figure out what it's doing. And if there's something that you want or interested, yeah, it's a free app.
I just had a question. So you compared with ChatGPT here. So is it like compliant with like, is it tracking our whatever data we have uploaded to the system, or like, I don't know, or it might be
Yeah.
a wrong question because because I know GPT is like open model, but like when we use here, is it a closed server, or like is it still like open model that we are using here?
No, yeah. I get what you're saying. So this either one, I'll try to hit multiple points of your question here. So either one of these is going to be the same model, Azure GPT-5 Chat. The one on the left is just fine-tuned with some instruction and data. The one on the left is just plain vanilla out of the box. The data
Okay.
that's captured within this UI, so any of the chat messages that are stored, so you can see all these chats on the left. I've got, all sorts of, various different things in here. All of that
Okay.
data is stored within our virtual server environment. So that's absolutely not out there on the internet.
Okay.
Any of the data on the back end created, in the workspace or the configuration, again, all internal. The only thing that leaves our internal environment, which it only goes to our Microsoft tenant, is the actual token transaction between the LLM and our chat UI you see here. So again, that goes into that specific tenant or subscription that we kind of showed last week. And ultimately, that is where all of that data is kept. So under this UC GBT, you go to the Azure Foundry. This has an API key and a deployment resource name, a URL ultimately, and the connection goes from our virtual server environment through our firewalls directly to Microsoft, and we've had those connections already pre-plumbed for all of the other various Microsoft transactions that we use. So in terms of what you're asking, it never leaves our environment,
Oh,
our
okay.
control. So it
Okay.
never goes out to just unprotected internet space.
Oh, okay. So when you refer to tokens, that means like we have purchased those tokens so that we can have internal data, or like we are securing our data and not exposing that to outside entity or something.
Exactly. Yeah, and I just use
Okay.
the
Gotcha.
term tokens because that's how it's represented in terms of any of the usage online. And what that means is when we talk about, let's say, a megabyte of data, right? That makes sense to us because we've really gone through the evolution of what a megabyte looks like over time. You could have
Right.
a picture that was 144 kilobytes, and now they're up to 35 megabytes. Like, we understand that concept. What LLMs don't, they don't see things in terms of file storage capacity. So what they've done, no matter what kind of data that's being ingested, whether it's image, video, audio, text, that then gets turned into integers. And the number of integers that are strung together into a unit is called a token. And so that's how LLMs and the whole AI factory, they do their kind of unit measurements. It does get kind of convoluted, but totally all within our environment that we control. Nothing egresses, nothing being trained. So any of the responses, any of the tokens, and so air quotes, that get sent to these LLMs, none of that gets captured by either Microsoft or OpenAI at the very minimum, and then obviously not anybody out in the internet.
Mhm.
And they don't use them for training. They don't use it for any type of internal analytics. It's strictly within our subscription, and then you can actually say that they would be segregated between subscriptions. So let's say we
Okay.
created another one that's not UCGBT. It's VPRI GBT. That would be
Mhm.
completely isolated from my environment. So if that
Oh,
kind of.
gotcha. That's great. Well, amazing. Thank you so much for explaining in detail.
Yeah, not a problem. And I think while I'm here, I'll hit on a question that Nathan asked last week about kind of specifically how do you deploy a model. So once you've built a subscription in this Azure portal, then you would give it resources. There's a whole host of configuration that you got to do in the Microsoft side of things. But once that's all done, then you can create various resources. So in here, I have these four. I have a resource group, which has quite a few other ones, but UCGBT is what you see quite often that we're working in. AI voice is the transcription services back and forth, whether it's speech to text or text to speech or real time for that matter. And then ACS is a Azure Communication Service, which is not a part of AI really. It says UCAI, but it's not being used for AI at the moment. But yeah, really, you would create this deployment of the OpenAI Foundry. Once this opens up, we go into the portal, and it literally, other than having these deployments already in here, this would be blank. But this is exactly what you would see. The whole kind of UI looks this way. Then you come in here, deploy base model. There's obviously fine-tune models and all sorts of different options there. And then you pick which model you want. In this whole section, this is just the Azure OpenAI. So it just has those models, whether it's router, audio, 5, 4, 3, all the various models. But you can also go into this model catalog, and that's where you can deploy many of the other non-OpenAI models. And I wonder, they still haven't put that easy link back in there, but there's another model catalog that gives you all of the Llama and Meta or Hugging Face or the Stable Diffusion that we were talking about. It gives you all access to all of those. So just kind of walk through that real quick. I'll show you GPT-5 Nano. I don't double check quick, but I don't have that. One do I not? Look at this. Confirm. And then 250,000 tokens per minute. That's pretty solid. I'll just deploy as is. And now I've got this target URI. So in terms of API, I virtually just go in. We can open Playground and show you the code that you'd want to use. But you can use this basic code either in VS Code in an editor SDK, or you can compile an API call out of this. You can change it from Python to JSON to curl, Java, Go, whatever you want, whatever is comfortable for you, and then hit this model. Right, this is a deployed LLM. So down here you've got your frequency penalties and different controls that you can put on that, but this is really all there is to it. And then different key authentications if you want to do that. But currently what I'm doing is I utilize that API key, which is going to be really the same for all of my models under this deployment. And I use a service. Let me see if I even have it up right now. AI. Let's see if I There we go. All right. So then I come in here. This is called LiteLLM, and there are mixed reviews on this. In my opinion, for what it gives you in our environment, gives you access to all of your models. And this is kind of the same thing that Model Router or Perplexity or some of those other ones give you, where you can have all of these different models playing together in the same place. What this gives that those don't, in my opinion, is the input-output cost and the controls. So you can set up different teams. You can set up different resource allotments or limits or thresholds for models or different groups, things like that. All sorts of various options. So I bring all of the models in here, and I can just add new model. We'll say sure feed audio. It might fail. Let's see. We got to change this mode. Ooh. This one I know will work. Test connection successful, and just for good measure, we'll add that model. So now that model is added. If we go to chat, should be able to find that in the list. There it is, right there. Interesting. GPT-4 architecture, okay. Well, basically, in a nutshell, Nathan, that's how I add models. And then once I have all of those, and really, again, those are just endpoints. So putting it in that LiteLLM package and then pointing OpenWeb UI at the LiteLLM instance to actually pull those models in is just the easiest way that I found to interact with a large number of models without changing your underlying infrastructure every single time. Because a lot of times when you're programming an app or an agent with a specific LLM, it can get kind of cumbersome to be making those code edits so frequently. All right, so I think that was pretty much where I wanted to go. Tools is kind of the same thing as prompts. These are packaged either Python code, JavaScript, and ultimately it gives the agent a set of instructions in its language that it can understand. So this one is specific to web scraping. So as it goes through any web searches and wants to actually pull down information on those web pages, it uses a free Gina API key. And then, yeah, I don't know exactly why this is free, but it does work. So I've continued to use it. And ultimately, that's use at your own caution. I would not scrape unethically, going to websites that obviously have disclaimers that they don't want that information removed or behind actual logins. Probably not a good idea to scrape. But for nice, easy searches for Wikipedia or Brave or Wolfram Alpha, things like that, it's very handy. So there's a kind of unlimited number of ways that you could take this, and so many different options. I've really just started scratching the surface. There's also what they call functions, which is I wouldn't call it a pipeline, but you're getting very close to having a data pipeline. So the function can actually reach in and go to another application and start interacting with that application. And that's where we actually get into the next bit of this. So as you can see, I've got a couple of different functions here: real-time voice, Power Automate, to show you kind of the one that is in the most production-esque form is this tier 2 support. So this Python script is basically just connecting to this webhook. It does some fancy things, emitters and waiting messages, error validation, but really that's the core of it, is that it's connecting to this webhook. So this webhook comes from another application called N8N. This sits on another virtual server in our environment. Again, completely secure, completely backed up. But what this has that the other didn't is access into some very specific information or databases. So the one that we'll be showing, and I'll actually just run a quick demo of it so you can see what we're actually working with. There you go. So this is actually going to reach in, and the way that I have it set up, I'm not going to be able to trap this one specifically until it's over. So I'll show you kind of the workflow in a moment. But to show you the output, currently this is what we have in the IT operations queue for all of my teams. So let's just pick one. Oh yeah, this is interesting. So not only can it, compile the list and give you the overall look of when things are created, when things were updated, modified, it can also reach into the actual comments, the description, and then I've got a couple of options here. I can say, do we have any info in Confluence or Microsoft resources or help resolve this? And that was this thinking ... is part of that emitter. I'm working on changing that to the actual streaming processes that it's coming from, because it's in another application where the workload's actually taking place. It gets a little funky on the code, but as you can see, it comes in and says, here's some of the relevant information. That's actually very helpful. I didn't really think about that. So might actually have solved this problem for real and just playing around with it. But goes in, that's the same ticket. Let's say I just want to make sure it hits all the various tools. There we go. Okay. So that speed, I want to reference how fast that came back, as opposed to how fast some of the other ones, or how slow some of the other ones have come back. And I'll tell you why here in just a minute. But these links, you're going to find kind of the same thing. They should work hypothetically, but for some reason, how it's actually referencing the URLs out of the tool, because they're missing what it's missing here. This one actually might work. These ones are all missing a very specific .docs learn.docs.microsoft.com. So why it's pulling that out, I'm not sure. But if you pulled that information in Microsoft, it would actually bring up the correct page. Now, for the look at what this was actually doing in the background. Let's see which one. Okay. So you can see there's a lot of different workflows going on, but this is where I had asked it what the specific information was that it found. And so when it accessed this Microsoft MCP tool, and sorry, I'm going to try to zoom in here a little bit. So the chat came in via the webhook, went to the agent hit the model, hit its memory, which is using a Postgres database, a relational database, and it just holds those chat messages. It then reaches into the execute MCP tools. And so execute MCP tools is something that is very unknown. And I think I'm still learning what MCP is, how to configure it correctly, how to access these things. But you can see when it comes back with some of that information, it's so much faster. And I'm not exactly sure what the error in this response is. I'm going to have to go through and see exactly what it's pulling. But the MCP is Model Context Protocol. And what that is basically, it gives the agent or the AI model, whatever you're using, whether it's fine-tuned or just basic LLM, it gives it its natural kind of code-based instructions on how to access that tool's information. So instead of using just large amounts of API calls, which all of these down here equate to basically one of those. So each one of these is a different API call, one to search knowledge base, an API call to search catalog, the feed, the open tickets for Exchange, open tickets for ops, open tickets for phones, and then ticket search is like the details of the ticket. So it's got to run those commands all discretely, whereas the MCP tool gives it that access all kind of in congruence or in parallel. So that makes it just way more efficient. To kind of show you the back end of those individual calls, because I think that's actually very important, and to kind of hit on the RAG and make sure that we're conscious of time. Let me see. There we go. Okay, so this is basically how the contextual RAG that I had referred to is laid out. The first part of this all really doesn't matter. This is just kind of parsing out the correct pieces of Confluence that I wanted to access, filtering out those responses, and then editing individual pages that I wanted. The real kind of nuts and bolts is this data loader split out LLM chain and then into the data loader. So as the API calls go through, and I've looped this a couple times before, so you can get a list of all the individual URLs, page URLs of Confluence, or page URLs of a site, or being creative, any number of things, right? You take that list and then you say, okay, I want you to filter out, with this criteria, taking that to a smaller list and then piping that into another request. These are all just kind of sequential steps to pare down a large list of URLs to a small list based on the information or criteria I want. You could also do that in terms of an Excel spreadsheet or values in a SQL table, things like that. But once that gets here, you kind of two options. If it's not a lot of data to chunk through, you send it all at once. Most of these models can handle quite a bit of ingestion at that point. But if it's something that you need to split up, you can have a loop section here to go over the list that you created and then just continue feeding that in through this process. But what this does is basically, let me see if I can pull this up. This will authorize the API to pull down the page information. Once the page comes in, all of its HTML or what body it has, it'll actually go through this line of code. And to not take you through the minutia, it basically takes 600 characters and with no overlap, and then creates chunks out of those 600 characters, whatever they say, whether it's metadata, whether it's header information, title information, whatever. So that ultimately brings it into 600 character chunks. Then it's sent into a kind of categorization of those chunks so that the next LLM knows what to do with it. It's not just HTML chunks. It's a body of responses. So output, JSON output. Once it comes to this LLM, this is just a basic, model router. So I've got it choosing what model to use based on the information that it's given. But I can put in here, here's the actual page URL. Here is the chunk that we want to situate within the whole document. And then I give it the chunk. And then I say, please give a short, succinct context to situate this chunk within the overall document for the purpose of improving search retrieval of the chunk. Answer only with the succinct context and nothing else. So as that comes back, we then apply the chunk. We then add a created date for meta. We create the overall text. And then we create, title, parent ID, URL, last updated date, things of that nature. When that all goes in to this is a quadrant vector store, but basically utilizing OpenAI's large text embedding. This will use batches of 2,048 batches, to bring those documents in. Now, that was very specific to a process that I was doing. I would probably change this with like a 10, 5 to 10 to start off with. But again, that is based completely on the process that you're doing. And then default data loader, this is the step where I take that chunk, give it the title, and then put the context behind it of what that means in larger scope of the document. So I don't have to put the whole document in every single chunk. I just have to put the reference of how this chunk relates to the overall document to actually gain that value. So then this ultimately, if we go back, let's say chat. So what is our dress code policy? Hypothetically, if I did my job right, there we go. And I might need to fine tune the instructions to make sure it gives the URL every time. Let's see. And because, there we go. So because it's pulling from a RAG database, and again, not scraping that live, it just has problems with those URLs. So that's definitely something, you can fine tune and work through, like I did with that UAM doc, and again, just lining up those individual URLs. But really, I'm very hungry to get a crawling agent and basically allow that to be one of these tools, and then just give it either direct access if it's not something that's sensitive information in cloud-based, or give it privileged role-based access and fine-tune kind of the permission set behind the scenes. But that way it's not doing this kind of static relationship with URLs and references. But in terms of what it can access in real time, it's impeccable. and things like the TDX tickets. I was able to actually get that working really relatively easy and consistently. My team's been using that for 3 or 4 months now, and they haven't reported any issues with the URLs. So again, it's just a fine-tuning kind of process. But what I think that other where the screen. What I think this workflow really illuminates for me, and what I think is good for others to look at, is just the step through of non AI functions within an AI workflow. So AI doesn't even really take place until here. So the LLM influence of this whole workflow is only in the last 75 or the last 25% of this whole workflow. All of this is just regular code going through, and to show you kind of what this is. Hit this website, get all of the spaces back. Based on the spaces, spit them out into results. Each result I want to filter by does not contain this space, does not contain this space, and is a globally accessible public space. Then from that, it'll get me all of those pages from those spaces. And then from the pages, I then spit those back out and get the IDs for those individual pages. If it's not null, I don't want null pages. So once I get that, go to the setting the title, ID, and URL of that page. And then that's ultimately where it gets all that information from. So this API grabs that page info, pulls it into chunks of 600 characters, and then spits it out into a list so that this LLM can categorize it. But that is extremely powerful when you apply that to search methodology in how you're doing any type of research, but maybe validation research or something kind of past tense in that sense. You can also inject, one of the things that I've been working on is more of a proactive approach, where you can inject actionable Power Automate flows. Ultimately, all of this comes back to this webhook, and we'll show you that quick. Where was it? Oh, there. Okay, so this chat creates this webhook. This is just an available entry point to this workflow. There's a lot to the backend configuration of how this actually is able to be hit from Microsoft. And for the most part, I have it working. There's some kind of authorization things that have broke, but all intents and purposes, and for what we're showing right here, this is perfect, because this webhook is something that can be hit from, let's say, Teams or, again, Power Automate. So if you already have a workflow doing work in a Microsoft system, you can actually just directly dump into this workflow from there. So let's say you have a set of documents that you're wanting to keep a very specific record of any version changes or any updates that people are making. So ultimately, beyond just an automation workflow where you'd say, hey, send me a message every time this specific Excel file was updated, you could actually then have the AI agent spit that into a workflow where now the AI agent is inspecting that update, inspecting that version change, and then providing more of a granular analysis of what happened, why that change happened, not just, hey, something changed, but hey, this is exactly what changed on this date. This is the reasoning that X, Y, and Z gave for this change, things of that nature. So the workflow aspect, and again, it's not necessarily a secured by default method. There's a lot of back-end work that I took to make sure that Microsoft connecting to this webhook was a safe connection. And that's done through what we call an app registration and enterprise applications in Microsoft. So a lot to that, but ultimately totally possible for any other group to do. But yeah, this is kind of where I've been living as of late to kind of show you that. Does anybody have any questions? I know we're getting kind of closer to time.